Good morning. It's morning in London. Good afternoon, Sydney. Good morning, New York. And it's still good late night in Hawaii. New Zealand, good morning, good afternoon, good evening, good morning, good afternoon. Who knows? We've got people from all around the world in this group. Today we're doing quadratic equations. Seriously? Wait, what? I'm expecting you to do quadratic equations? Well, we're going to start making it simple. And in the activity, as always, these amazing activities that we've been given by AIMSEC, but the AIMSEC are creating for the Aiming High website, is a low threshold, high ceiling, which means that you can come in there at whatever level you want. And we're going to start with, so remember, for early years, we're going to do an even simpler activity, but equally mathematically rich at 10 o'clock in 59 minutes. And for now, we're just going to be starting with handspans and wait for it. Just put my special happy socks on and ooh, feet. Oh dear. Right, now, let's have a very quick share so that I don't know why they bother. There we go. Hello, there you are. And I'm afraid I've completely given up now on seeing the comments that are in the group until afterwards. So I will, until I have somebody technical to help me with this, let's just kind of, I'm going to give it one more go. I'm never give up. Never give up. Never, 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 never. I'm going to pull it up here and I'm going to play it and be watching this as best I can while I'm also facilitating. See if I can. What's this? What's this? What's this? Okay, play. All right, let's give it a go. See what happens. Now, quadratic equations. We will come to quadratic equations, and the way we're going to come to them is slowly, nice and slowly. As I say, we're starting with hands and feet. So I'm now going to share the screen so that you see, well, I'm going to look at the screen anyway. Let's put it that way. Find the right page I need to be on. Here it is. So starting off with age 7, you know what? I enjoy these activities no matter what my age is. So age 7-ish. If you're in primary school, in elementary school, this is going to work. So what we're going to do is we're going to start by measuring. Going to measure my handspan. While we're at it, I'll measure my foot length. So I think, yes, I'm going to do it on here. Don't need to use a visualizer because we've got my lovely friend here. Do need to see what I'm doing, what you can see. Right, here we go. Bring it around here. There we go. Now it's going to be interesting doing my foot size. I'm going to draw it on here. You can get a measuring tape or a ruler and measure it. That's kind of hard for me to do with one hand. You can, of course, I could do this. Measure it like so. Okay, so that tells me it's 19, my hand span. Now in the image, it does that. I do my hand span like that. And then if I'm measuring across, I do that and then I move on. So if I was measuring this board, which I'm going to measure in a minute. Okay, you know what we're going to do first of all? First, before we do anything else, we're going to estimate. We're going to all estimate the size of this board. And I'm going to write mine down here where you can't see it. I'm going to estimate I don't know. That's my estimate. Oh, there you go. I've got my estimate. And now, let me stand by it because, of course, it's a bit of perspective issues here. I am about 163 centimeters, 162, something like that. If I stand next to it, does that help you at all? Put my arm out. There you go. Oh, by the way, I am 1 meter to the end of my thumb, from my shoulder to the end of my thumb. I know my length in my body horizontal, my arm width and my height. And my height, oh, by the way, is 1 meter up to here. So if that helps you. And the board ends, it's just below. You can't see, well, let me lower it down a bit. There you go. Board ends there. Okay, so it looks a lot longer than it is, okay? The proportions don't look right, because this is, if you see this is curved here, it's because we have a fisheye lens on the camera, which means everything's a bit distorted. Right, so it's a bit hard for you to do that, but you can do it. So I'm going to actually do it. You can measure your hand itself, but I'm going to, whoops, that's not very accurate. I'm going to go right around your finger, and if you're like me, you're drawing all over it. Whoops, I'll stretch it out properly. Not doing a very good job here, am I? Right, stretch it out properly. And there we have it. You can finish drawing the whole hand. And now we can measure. Let's see how close to 19.5 we get looking at this. Well, yeah, so this is a bit bigger. Remember that when we're drawing around it, you add some extra, let's there's an extra perimeter, there's an extra length between where, distance, I think is the word I'm looking for, between the end of my finger and where the line is drawn. So let's actually measure just inside that finger to just inside. So it's quite a lot. It's actually about 0.5 centimeter. So whatever you measure, take 1 centimeter off whatever you measure, because it's about 0.5 centimeter there and 0.5 centimeter there that I've added by drawing around my hand. So take 1 centimeter off. So 20.5, the actual distance is 19.5. Take off that centimeter and you should be grand. Now, that's my hand span. So my hand span, I'm going to say is 20 centimeters, because 19.5 is quite a hard number to work with. So it's good enough, 20 centimeters. And now my foot. Am I serious? Am I seriously serious? Here we go. Ooh, what was I thinking when I thought of this one? I've got my balloon socks. Can you see? Oh dear. Okie dokie, here we go. My foot. Oh. I'll have to finish this one artificially. And now I'm going to measure my foot and measure this and see. So where am I going to measure? There we go. And to measure from the tips, it's quite hard to do. I think it's a lot easier to do this. If you go to a shoe shop, if you can, and use one of those things so that you've got the vertical measures, vertical there and vertical here. So if you can do that at home, you can stand on the floor and actually get someone to put something vertical there and there. And you get a lot more accurate measure. In the meantime, as best as I can work it out, we've got 24 centimeters. So that's eyeballing it very definitely. Let's see what it comes out on here. Oh, I must have gone in. I probably went in slightly as I was drawing it because of my foot. You can actually bend the pen inwards a bit as you're drawing it. So that's about right. That's about 24 centimeters. So this one's 20 centimeters. Oh, there's a connection there. I wonder if there's a connection. That would be interesting. If you all measure your feet and your hand span. It's not that far different. Now I've got to do it this way. Oh, if I can. Here you go. I've done my yoga this morning. Yeah, it's not far different. It's a little bit, my foot's a little bit longer than my hand span, but not much. Why don't you all test and see if your hand span, how different your hand span is to your foot length. And that goes for grown-ups too, by the way. And then can you send us pictures, please? Send us lots of pictures, especially video. I should really do this. I am videoing it. Oh yes, of course I am. This is so going to be a very fun activity when we put this one on YouTube. Okay, so we've got a hand span, we've got our foot length. Let's see what we're going to do with it. we are going to measure something. So you might want to measure a table. You might want to measure, yeah, actually, good point there. Something to just ask yourself in the process is, what is half your hand span? Which is actually quite nice. We've got the 20 centimeters. So we've got my hand span. Let's put it here, hand span. So we've got 20 centimeters, that's 1. What's half of it? How long, whoop, I'll put it, no, let's put the centimeters here to make sure. We must always put the dimensions. If we're talking about a length or a weight or anything that's got dimensions, we have to put the dimensions on. The units, I mean the units. What's half of 20? And then also, what is a quarter of 20? Which is half. So it's half again. So it's half of a half, and a half of a half is quarter. So if you had a pizza and you had half of it, but you weren't allowed to have half of it, you could only have half of it. How much pizza would you get? How big would your slice be? What fraction of the pizza would you be eating? So that's nice and easy for me. Mine's 10 centimeters and then 5 centimeters. I don't know why we have to know this, but we've got the measures we've been asked for. Now, I'm going to measure this board. I'm going to measure it using my hand span. Now, I wonder how my right hand, because I've measured my left hand span. Oh my goodness. Wait a minute. Oh, well, I said it completely wrong. I said 19.5 to start off with, but actually my hand span's more like 21. So this is actually quite close to being correct. And that one, look at your left hand and your right hand span and see if they're different. See if you're symmetrical, which most people aren't perfectly symmetrical. Now, I'm going to measure the board. You measure something. You go off and measure something. I've got to make notes so that I remember. Okie dokie. You go off and measure something. I'll measure this. Whoopsie. Remember, I've got a microphone on me. Don't want to demolish the microphone system. Right, so 1. I could mark it, couldn't I? Could mark it here. What I usually do is 1, 2, 3, 4, and it went up to there. I'm going to mark me. Went up to there. Or you can mark it that way. 1, 2. For goodness sake, don't mark the table. 3, 4, and that much, which is, yeah, it's about right. So that's 1, 2, 3, 4, and we don't know how much. 4, and how much, we don't know what fraction yet. And then across the top, I found both my hands are about the same. So 1, 2, and 3, just about 3. So it's 4 and something by 3. Now I'm going to actually use my ruler. I'm going to use my ruler to find out what fraction that is. So that takes me, basically it's 8 centimeters, less than a half, but it's not 5 centimeters, it's more than a quarter. So we're going to round it to the nearest quarter centimeter, and the nearest quarter centimeter is a half. So not quarter centimeter, the nearest quarter, nearest fraction, the nearest half fraction. Right, so we're going to say it's 4.5. It's not very accurate because it's not exactly times 3. Or the other thing we could do is it's 4 hand spans plus 8 centimeters. And we have to work out how many centimeters the hand span is, and then that's times, whoops, and then that's how long it is, and that's, I'm kind of getting ahead of myself there, saying times. It's, oh yes, 4 by, it's 4, that's time by that, so it's the length of it is that length by the size of it is that by that. So it's that length by that width. That's what the way that we say it. And we are, if we want to know something else about it, we would multiply them together. But I'm just going to change that to by. I kind of just wrote that automatically. Remember, I'm not a teacher. I use maths. I'm not a teacher, so I automatically go for things that I've got the habit of doing over all these years, and I'm an engineer. So, but that's not helpful to you when you're just learning. So I have to adjust some of the things I'm doing and think, wait a minute, what am I saying by putting that cross there? And it's not what we're looking for. We're not looking this. If you know about this, is the area is if you do the length times the width, you get the area, you get how much space there is, how much wallpaper you'd have to use to cover it. But that's not what we're looking for here. We're looking just for the length and the width. So it's 4 handspans plus 8 centimeters long, and it's 3 handspans. Now, can you see that? Wait. That's better. It's a bit better. Okay, we're not going to go that far down. We're going to go here. 3 handspans wide. I'm going to get rid of that. 3 handspans wide, 4 handspans plus 8 centimeters. I think saying half or a quarter was too far out of what was actually happening there. Long. Okay, so 4 handspans plus handspans plus 8 centimeters. Well, how many centimeters is 4 handspans? Well, I did make it nice and easy for us. So 20 centimeters plus 8 centimeters. Whoops, 20. So that's 20 times 4. And then we have to add the 8 on afterwards. 20 times 4 centimeters plus 8 centimeters long. So 20 times 4, 80 centimeters plus 8 centimeters. Oh, that's a nice figure. Look at that. 88 centimeters. Oh my goodness, it's 11 times 8. Do you ever do that when you get a number fact? You're like, oh, 88. Oh, I like that. It's 8 times 11. It's 11 centimeters, 8 times. And then the width. Well, the width is 3 handspans. So it's 88 centimeters by 3 times 20, 60 centimeters. So according to this, it's 88 centimeters by 60 centimeters. We've worked that one out. What have you worked out? What have you, can you send us, put a message in, send us pictures of what you've measured, and just join in and let us know what you're doing. If you can even manage videos, that would be amazing, because that will help other learners. Putting the top on my pen. That'll help other learners. Right, now let's see what we've got to do next. We've measured something. How many handspans is the length? How many handspans is the width? Now, the next question is, how many handspans is it in all? We've gone straight to centimeters, but now we're going to go back to handspans. And we're actually going to move all my lovely magnets away. I do like my magnets, but they're using up my real estate here. Okay, so now we're going to approximate. Now this is going to introduce error. It's going to introduce inaccuracy. It's not going to be exactly right, because we're going to now say it's 4.5 handspans. So if it's 4.5 handspans long, how many, and 3 wide, how many handspans is it if we get through those handspans plus those handspans plus these handspans plus these handspans, and how many handspans would it take to measure all the way around the whole board? And you do that with your one, whatever you measured. We now want to know how many handspans it is to go around all of what you're measuring, a table or a carpet or something. Right, now, so mine is 4 4.5 times 2, there and there, and we've got 3 times 2, so we've got 9 handspans, and we've got 6 handspans, so that's a total of 15 handspans. And then you can go and convert that to centimeters. Now, in other words, you know how many centimeters, we also let's just go ahead and do that, because I think if we make that into centimeters, so we've got one hand, oh my goodness, oh, we're going to do some real jiggery pokery here. This is definitely upper primary now. So we've got 20 centimeters is 15 handspans. So then you've got to work out how many centimeters it is in all. And then you can compare that with what we said, is we also said it was 88 centimeters, and that the other one we worked out. So this would give you an answer in centimeters, and this would give you an answer in centimeters. Two of those, 88 there and 88 there, and compare those two to see just how much error we put in by approximating to 4.5 handspans rather than 4 1/3 is basically what it was more like, 4 1/3 than 4.5 or even 4 1/4. So we've introduced quite a big error by rounding that to the nearest half. Right, so you can do all of that. I'll leave that to you. Now, the next thing, and you can come back and replay and stop it. So we've got the perimeter, and then we've got the perimeter in handspans, and then we can work out the perimeter in centimeters, both accurately and inaccurately. Oh, wait. It's 88 times 2, and we've also got to add, right. Or we can just add 88 and 88, and what was the width? 60 and 60. Or we can say 88 times 2 plus 60 times 2. And the reason why we draw formulas like that is that it's a lot clearer, especially if we have a lot more than 2 times. If we've got 20 times, it's much easier to write 88 times 20 than to write 88 down 20 times and add them all together. So that's why we evolved into multiplying. Right, so now you can then also you can move on to using measuring tapes. You can use your feet. I've got my measuring tape here, so you can measure different things. You can measure the windows, you can measure carpets, you can just measure different things, measure toys, measure whatever you want to measure, and work out what the perimeter is of the different things. Now, perimeter is flat, so you could even measure your garden. And I don't know if you've ever watched Our Lives before, you'll have seen we've got our paper sticks. You can use these to measure perimeter as well. You can see how many paper sticks it would take to go around the whole table, make enough paper sticks to do it. And then you can still use those paper sticks to make other shapes and things. Paper sticks are great. And you can make the meter-long paper sticks to measure the garden. Make them a whole meter long, using multiple sheets of newspaper, roll them up, put a string in the middle, tie them together, or simply use that one string, just like we use the handspan, and see which is more efficient, using the handspan to measure the whole garden or the whole living room or the whole room, the whole place you live in, or is it more efficient to use a 1 meter length? And then you can maybe use your handspan to measure the remainder. So there's various different activities to do on the activity pack. And the other thing you can use is you can use string. Well, I don't have enough string, on a little bit of string I've got left. I've got to go and get some more, but I'm going to use a cable. So you can use a cable to measure, or you can, I've already pre-measured some cable, like a meter length perhaps. So I do have had a meter length piece of string somewhere, but I don't have it now. You can use a piece of cable. That's how wide it is. Now you can take it away and measure that with more ease, or you can take the length and measure things like that. If you have a particular length, the example given here is if you actually get an exact length and tie it string to one finger into another finger, and you know exactly how long that is, maybe 50 centimeters, maybe a meter, and you can work that way as well. And of course, I know my meter length. My meter goes from my shoulder to the end of my thumb, fully stretched out. And I do use that. I use that to measure all the time. And of course, you can also work out how big a stride you have to do to make a meter as well. You can take a nice big stride, and that can be a meter, and you can test it. You can keep going back and forth doing different strides until you and measure it, so you know what the distance is. Make sure your stride, if it's 5 meters, make sure that you do 5 strides to get there. And then and if you do that often enough, then you'll know how big a stride you need to step to measure a meter. And that can actually be, I promise you, can be super important. It can be useful. It can be very useful. So there's an activity in here where you can measure some curtains. So you measure a window, and then you've got to work out. Now this is, now we're talking we're in secondary here. We're in from the ages of 11 up. You can measure a curtain, measure a window, and then you've got to work out A, how much curtain material to get, excuse me, and B, how much it's going to cost. Now in our resource, it gives Rand, it gives in South African Rand. So it actually tells you the cost in South African Rand, how much it is per meter. So you then have an additional challenge. You've now got to work out how much it is in your local currency. So do a currency conversion. Don't Google it. Don't Google it. Find out what the exchange rate is, but don't Google the answer. Find out what the exchange rate is and work it out. And then you can Google the answer and see how close you are to the truth, and you can work out how many South African Rand there are to your local currency. And the thing with curtains is that it's not just about measuring the window. This is real life maths. When you buy curtains or buy material to make curtains, the curtains don't lie straight. Blinds do, but even with blinds, they have to overlap, or the blinds can go exactly inside the space for the window, or they might have to overlap and go over the wall on either side. Curtains certainly go over the wall, and so that you would need to allow for the creases, for the bendy bits, so that they hang nicely, and they have to go further over on each side, and they want to be, well, not this one right here. This one actually goes floor to ceiling that I'm looking at here. But if it's just a space and a window, you want the curtain to go further out than the window, further up than the window, and further down than the window, and decide how long you want it. And then of course you've got the hem. You've got to put the hem on. So this all determines how much material you're going to get. And then we move on to quadratic equations. Now, are you ready? Now this is now for upper secondary, if you're 14, 15 to 18-year-olds. Now what we've got is a bit of a practical joke going on here. So we've got farmer, I'm just thinking of Joe, farmer Joe, Joseph. I'm not choosing too regional a name. I've seen Joseph used in languages all around the world, so we're going to use that. And then we've got his son, whose name is we're going to call his son Lima. We're going to call his son Lima. It's just random. Right. Okay, so we've got J and Lima. I don't know why I'm writing it down. We've got Joe and we've got Lima. Call him Lee. Okay. So they live on a farm. And Father Joe says to his son, oh, actually, thinking about it, what am I doing here? What am I doing? I'm an engineer. I'm a female engineer. We've got Lee, and we've got. I'm thinking of word names that can work all the way around the world. M. We're just going to call M. Lee and M. And Lee and M, boy and girl, of equal importance. They are asked by Joe to go and measure their pond to put a fence around it, because they found that the children were going to play in the pond, and they don't mind the children playing in the pond, but it's not very safe. It's not a safe pond for the children to play in. It's not easy to get out of, and they're worried that the children might get hurt. So Lee and M go to the pond to measure the J, L, and E, just to remind me. It doesn't matter what the letters are. Anyway, so here's the pond. There's the pond. It's got water in it. It's got a whale knot, but anyway, I'm going to write a whale because I want to. And it's got fish in it, lots of little fishies. And they're swimming around, they're happy. It might have a frog. Oh my goodness, can I draw a frog? What am I getting myself into here? There's a frog. There you go. Ribbit, something like that. So you've got all these animals in there, and we need a fence. So we're going to draw a fence around it. Boom, 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 boom. Now, Lee and M have just got back from school, and they're really excited because they've just learned all about quadratic equations. And their father, J, is always saying, and mum, and their aunties and uncles and grandma and all kinds of people, are always saying how they really want them to do well in school, and that they wish they were learning the maths that the kids are learning. So the kids go, aha, aha. They've measured it and they know what the distance is, but they've decided, instead of giving their dad the right measurements, well, they're going to give them the right measurements, so they measured it. They decided they're going to make him do a little bit of maths to find out what the perimeter of the fence needs to be, how much fencing that, let's see, no, it doesn't even need to be dad, does it? Just, it needs to be the owner of the farm, whoever, the manager of the farm, whoever it is, whoever needs to know how much fencing to buy. Now, let me just double check that I'm getting this right. Why am I doing this? Nothing, I don't need to do anything. We're good where we are. Right, so they come back and say, right, they know what the measurement is, and they say the area, they've told Joe that the area is 66 square meters, and that one edge is 3x plus 2 and the other edge is x plus 3. Now, I am not going to do the maths here in front of you, because this is all about you doing it. So if you would like to know, and if you download the activity pack, you will see it is beautifully explained. So if whenever you get stuck, go back in and look at the activity pack. I just want to make sure you can see what I've written. Yes. Okay, so you know the area, and you know what formula then works. That times that. So you're going to be, let me get the correct language here. As I say, I'm not a teacher. I'm just making sure we've got the correct language. What you're going to be doing is, you do need to do this. You do need to know about expanding brackets. So we are talking about people that know how to expand in brackets, and we're going to multiply the 66 square meters is going to be that times that. So we now know that 3x plus 2 times x plus 3 equals 66 meters squared. So what we're missing is we're missing x, so we have to break this down to be able to find x, and then we can put x back in those two equations. So it'll be that plus that times 2 to get us the perimeter. So over to you to work that out. This is really beautifully explained, but please don't look at the solutions until you've really had a good go. And then if you need to look at the solutions, have a look at it. And what would really help is if you go back and then review it until you really get why, so you don't need to look at the solution next time. And so throughout this whole thing, you've been learning about rectangular shapes, length and width. Because they're older learners, they have to know about area in order to solve this. We've got the product of 2 brackets, oh my goodness. And for the younger learners, we're just getting ideas about spatial skills, about how to work out the lengths and look at the perimeter. And we're developing critical thinking skills so that we can apply a question like perimeter to real life, or how much curtain to get, or how big a tablecloth to get, and how much, say if you want to cover a car, how much cloth do you need to be able to cover a car to keep it from getting all dusty? Or if you need to cover a sofa, or you need to cover a bicycle, how much material do you need to get? And all this will help you, because when you buy material, you don't buy it in area, you buy it in length. You don't, and that's an interesting factor. Right. So if you are enjoying these lives, please do share them. Please do join the group, or get other people to join the group. Tell everybody about them. That's making maths fun for kids of all ages. And we also have the 2 YouTube channels. So we've got the Maths Toys YouTube channel, and this video here is going to be edited and added to go onto that as well. So it's a bit more concise, and it's much clearer. There'll be little notes to say, okay, now it's for which years it's for. And then there's the Bubbly Maths YouTube channel, where we're uploading just the lives, unplugged lives. And then there's other activities on there to do with balloons and soap bubbles, and all to do with maths and Guinness World Records and all kinds of things like that. So please do subscribe to both our YouTube channels if you're on YouTube. And I'm now going to go and see if we've had, I'm not able to both do this and watch the comments. Oh, I don't know. The live did work. Yay. Barbara Davis. Oh, hello. Tom Francis. Aileen Patel. Andy. Hello. Barbara's back again. Paula, I'm hoping that means that Ziggy is watching. I hope so. I'll be very, very interested in knowing. And you know what? You can bet you can do some programming to work this out, but you don't have to worry about quadratic equations. You're not there yet. But I bet you can work out maybe to get your robot to travel using Logo, get your robot to travel the perimeter of this board, or any other shape that you might have, or to make Ziggy's into bubbles. So maybe to do a path of a bubble and work out what the perimeter of a bubble is, if it's all those, you know, the really big bubbles that are wibbly wobbly. That would be fun. You could get a robot to transcribe to draw the distance. Monica, hi. Vibeke, hi Vibeke, and how do you day? Vibeka's in Denmark, and Pal and Ziggy are in Wales, and hi Eddie, who's up north at the moment. Oh, and Tom, who's way far east. And now let's see see if we manage to get the comments from the live on the group. Oh, Jen, hi Jen. Bob. Thank you, Jen. Jen was suggesting, I think, the name of the farmer would be Bob. That's a really nice neutral name. Thank you. Oh, bless. It's great to see you, Jen. Thank you for joining. And so that's us for today. Thank you so much for joining. And please do send in your pictures of what you've done. Program your robots from the coding that we did yesterday. And do send us in your ideas, and maybe if you have any ideas that will help other learners to do things like solve quadratic equations. Joining, get participating, and thank you for coming. So now I've got to find my bit where I have to stop the live. Thank you very much. Wait a minute, it's going to go in it. Yes, thank you. Bye-bye.